Welcome to another class with Ming. Today we talk about test for independence. This is basically a test where you are trying to figure out whether two categorical data, for example in this particular case, where the choice of the color of phone cover is one categorical data, red, blue, green and white, and the other categorical data is gender, male or female. And let's say James, the student who are interested in this particular question, he could have collected this set of data where, for example, there are 43 female who like or prefer to have the red phone cover, 45 male prefer blue phone cover, and so on, with a total of 250. So in order to do this particular test, you could use something called the test for independence. Test for independence basically involve 4 steps. And here are the 4 steps. First of all, you probably need to write out the null hypothesis, usually denoted as H with a sub-zero. And this is basically about the independence of 2 items. So in this case, you can say the choice of color and gender are independent, for example. So the null hypothesis is always about independence, whereas the alternative hypothesis is about the opposite of independence. So you can write that as choice of color and gender are not independent. So regardless of what you think it is, whether they are related or not, this is the null hypothesis that you're going to write about independence, and the alternative not about independent. And the step 2 is to calculate the chi-square statistics. The chi-square statistics here, the notation here is this, chi squared with a CALC. Basically, this is the sum difference between the expected and the observed value, and we do not care about the sign, so we square it, but the magnitude of this difference really depends of the magnitude of the expectation. For example, if you have a value of 2, the difference, over the expected value of 4, then the magnitude is only half. Whereas if you have a difference of 2 over the expected value of 40, then this is a very small value. So we divide by the expected value. When we are doing variance and standard deviation, we divide by the number of observation, but here we divide by the expected values. And step 3, we find the critical value for comparison. In the exam, for example, the critical value is supplied by the question. But for project work, you need to know how to figure out what is the critical value. And the last step is comparing the calculated value statistics with the critical value. Basically, this critical value is a benchmark. So if my critical value is here, let's say this is my critical value over here, anything above it, so above the critical value, we will then reject the null hypothesis and accept the alternative. If it's below the critical value, if our chi-square statistic is below the critical value, then what it means is that this sum here could be very small. If they're very small, then it basically means the observed values are not very different from the expected values. That means the underlying observed values is actually very close being independent. So here we fail to reject H0. That is, we have to conclude that the observed values is actually independent, for example, and then reject the alternative. So basically, this is how you make decision.